It's Thursday, the 14th of November. My name's Juan Brown. You're watching the Blancolirio channel, and we're back in the hangar. And by popular demand, folks are looking for more information on what happened to the ERJ 175 flight that departed out of Atlanta, Georgia, on its way to LaGuardia on 6 November and had a runaway pitch trim situation. On 6 November, about 9:06 p.m., Brickyard 4439 departed runway 9 left out of Atlanta on a routine flight back up to LaGuardia. This was a short turn, 45-minute turn out of Atlanta, heading right back up to LaGuardia. Within minutes of departing runway 9 left, the flight crew declared an emergency. And by listening to the audio transcript that's available on VASAviation, whose link I'll provide down below, a couple of things we can glean from this situation. Within minutes, this aircraft departed and started at a very high rate of climb. By the way, they only had 6 souls on board total, counting the crew, and just 12,000 pounds of fuel. This is about a 60 or 70 passenger aircraft. Within minutes, the crew declared within a minute or two of the departure, the crew declared an emergency. Air traffic control queried him as to what's the nature of your emergency, and the crew responded, "We have a trim runaway." Normally I call it runaway trim, but they called it a trim runaway. Twice they had to re-emphasize that to the traffic controllers. He didn't quite understand what the crew was telling him. Later he responded that we're in a stalling condition. And the crew also responded later, "We can't pitch down." And the crew later responded saying, "We're trying to descend." Upon departure on 9 left, the crew of Brickyard 4439 ended up doing one tight right 360-degree turn, followed by a second climbing right-hand turn of a much larger radius before getting the aircraft under control, setting up for a downwind for the runway 9 left or right back at Atlanta. The entire flight lasted only 20 minutes. Correction, it looks like the crew did a 360 followed by a 270 before turning another 270 degrees back around to the downwind for Atlanta for safely landing. If you look at the flight-aware data, it looks like this flight got up to a little over 14,000 feet. It had vertical speeds of exceeding 3,000 feet per minute, and the speed range, according to the ADS-B data from FlightAware, ranged from 160 to about 300 knots of airspeed. One of the most telling things on the audio transcript that's available from the air traffic control is when Delta Airlines Flight 2304 came on board after the aircraft was under control, while the Flight 4439 was on downwind to return to land. Delta 2304 offered his assistance as he was a former ERJ 175 pilot himself. And he asked, "Could I be of assistance?" And the crew from Brickyard 4439 responded, "Right now, we have it switched over to the FO side and it seems to be working. We just got system 1 and 2 cut out." That explains a lot of information we're going to dive into here in a minute. Again, from the crew of Brickyard 4439, "We're in direct mode now and it seems to be working okay." Now, in a little bit of incrimination, Delta says, "Did you guys follow the QRH?" That's the Quick Response Handbook, the emergency checklist. Brickyard says, "Well, we didn't have time, to be honest. We had to fly the plane and parallel fight the airplane at the same time. We'll be on the ground soon." So the crew of Brickyard 4439 had some sort of a runaway pitch trim and or elevator control problem. It took them a while to get it sorted out, but they fought and flew the airplane. They eventually did get it sorted out. Let's take a closer look at the systems of the Embraer 175 as with these modern computer-controlled aircraft, this is not your grandfather's Runaway Trim. Of all of the aircraft I've flown in the past, the Embraer is not one of them. But if we look through the manual, we can see that the Embraer is a hybrid of fly-by-wire technology along with conventional controls. In the ailerons of the Embraer, they are conventionally controlled with steel cables and pulleys right through the flight controls. However, all of the pitch trim, all of the stabilizer, elevator, and pitch trim is controlled by fly-by-wire technology. When using fly-by-wire technology, when everything is going normally, the aircraft is what's considered in normal mode or normal law. In Airbus aircraft, which led the way on fly-by-wire technology in airliner type aircraft, you have three different laws: normal law, alternate law, and direct law. In the case of the Embraer aircraft, it appears that this aircraft has simply two laws: normal law and direct law. What is direct law? Direct law is a direct input from pilot input on the control yoke to control output in the case of the elevator. Why do we even have fly-by-wire technology? It's the wave of the future. It's the way all these aircraft are going. It's the way that eventually we're all going to be programmed out of a job as pilots in the distant future. Fly-by-wire technology allows engineers several advantages. You save weight, cost, and complexity of mechanical systems, and you also can add electronic stabilization features and protections to protect pilots from some of the normal things that pilots do to cause accidents. For example, stalling the aircraft, flying too slow, overspeeding the aircraft, flying too fast, overbanking the aircraft, and losing control. These stabilities can be built in electronically using flight computers via a fly-by-wire flight control system. Fly-by-wire technology has long been used by the military because their aircraft are inherently unstable to increase maneuverability. However, airliner-type aircraft are required to be inherently stable designs as per the FARs, so that when flown in direct law, an airliner-type aircraft is an inherently stable design. It simply loses some of the protections afforded by the fly-by-wire technology. Additional enhancements in the Embraer aircraft specifically that are done electronically now through the fly-by-wire system and the onboard flight control computers are, for example, Mach trim. As you approach the high speed limit of the aircraft, you can get some slight trimming of the elevator to prevent any tucking from Mach tuck. You get power and pitch change trim inputs automatically. Remember with the 737 MAX, one of the problems they were trying to fight with, that they were trying to cure with MCAS, was pitch changes as you push the throttles up. Anytime you push the throttles up on an underslung engine aircraft, you're going to get a pitch up moment, and you're going to need to trim the aircraft down. That kind of stability can be built into with the fly-by-wires and the flight control computers. In the Embraer, I saw they even have a tail strike avoidance program, which will limit the amount of up elevator, which will help prevent you from smacking the tail on touchdown. And of course, they can build in stability when you make configuration changes of the aircraft to help minimize the amount of trimming that you have to manually do. For example, when you lower the flaps and you need to trim the nose down, or you lower the gear and that may create some pitch changes, that sort of stability can also be enhanced with the computers. But you need to know how to turn the automation off, and you need to know how to do it quickly. We learned about runaway pitch trim emergencies years ago, long before fly-by-wire technology. Unfortunately, training for this emergency has not changed much since. The elevator on the Embraer series of aircraft is controlled by 4 electro-hydraulic actuators. These 4 actuators are controlled by 4 pitch actuator control electronics modules, computers. The control actuator electronics receive signals from flight control modules, and the flight control modules receive input from the air data system, and all this is refereed by a CAN bus, a controller area network bus. If the network detects a problem with either the flight control computers or the air data system, it should drop out and automatically revert to direct law, where the pilot has direct control over the flight control surfaces. The status of the flight controls can be seen on the ICAS screen if you have time to reference this while fighting the aircraft. The crew can also force the flight control system into direct law by pushing the associated red guarded switch on the flight control mode panel on the center control pedestal. The stabilizer trim on the Embraer series of aircraft is achieved by moving the horizontal stabilizer through a similar series of flight control computers. Manual pitch trim inputs are done by a traditional trim switch mounted on the control column. The stabilizer trim in the Embraer can also be forced into direct mode by the crew by pushing both the System 1 and System 2 red guarded cutout switches located on the center control pedestal. With the system cutout, you can still trim the aircraft using the backup pitch trim circuit located here. Now let's look at the emergency checklist, and right away I can see why they call it Trim Runaway as opposed to Runaway Trim, as that's the title of the checklist here at Embraer. Note the condition statement is more than simply Runaway Trim. Note the two checklist items inside the black box are memory items. You simply do not have time to whip out this checklist and reference it. You need to do this from memory. Step 1, Autopilot disconnect button, press and hold. This is the red button on the control yoke that pilots are very familiar with and work with every day. Step 2, pitch trim system 1 and 2 cutout buttons, push in. These are the red guarded switches in the center control pedestal that rarely ever get used, but maybe once a year during simulator training. Now you can release the autopilot disconnect button and you see the warning, do not open the speed brake, and note continuous banking turns will help alleviate excessive pitch up tendencies. This in part explains the climbing corkscrew pattern off the ends of the runways at Atlanta while the crew was sorting this out, as every pilot knows that if you increase the bank, you reduce the lift. Now, if you go through the rest of the QRH procedure, it appears to be a procedure to attempt to reinstate normal stabilizer trim. I think investigators will find that this crew had had enough of this rodeo, and once they got the aircraft under control in direct law, they left it that way. Thus the statement, we're in direct mode now, and it seems to be working okay now. Now, what about the statement from the crew Brickyard 4439 where they said, right now we have it switched over to the FO side, seems to be working, we just got the system 1 and 2 cut out. As with all modern airliners, the air data system is a key input to the entire computerized flight control system. And like everything else, there's redundancy built into the system with two systems, a left and right. By the way, the Embraer uses these new smart probes from UTC Aerospace. The air data system provides the inputs for flight instrumentation, which is redundant, with each pilot receiving an independent set of data for their respective instrument panels. In the event of a failure in the air data system, whether at the probe level or with the air data system computers, the associated flight instrument cluster will begin to show bad data plus an assortment of warnings and cautions. Once the crew has sorted out who has the good data, the crew can bootstrap the good system over to the inoperative system using, in the case of the Embraer, the reversionary panel located here. So this is what I believe investigators will find out from the statement by Brickyard 4439 when they said, right now we have it switched over to the FO side and it seems to be working. So as you can see, runaway pitch trim may be the sign or the effect of a much larger problem in these modern fly-by-wire aircraft regarding inputs to the computers or the computers themselves. Because this was a problem involving a primary flight control, the NTSB will be getting involved and will be investigating this, and we'll have a lot more answers to our questions once we get the CVR, the cockpit voice recorder data, and the data from the aircraft itself, and lay that all out on a timeline. If this sounds a lot like the 737 MAX issues, it's the same thing but different. Remember, MCAS, the Maneuver Characteristics Augmentation System, is unique only to the 737 MAX. That particular system is not in any other aircraft. Thanks for your support of this channel, and especially thanks to my Patreon supporters, as these kind of detailed reports take a lot of time and energy to produce. Thank you for your support. We'll see you here.